Hello everyone, and thank you for joining us today for this webinar entitled Composite Structural Parts into Mass Production for Automotive Applications. It is brought to you by GEC Group and presented by Valeo, one of the leading global automotive suppliers from France. My name is Benjamin Debucher, and I'm Program Manager for GEC Group. Based on a lightweight Crashbox and bumper beam case study, this webinar will cover 3 topics around Valeo Organosheet composite material. First, the process and how Valeo succeeded in developing composite structural parts for mass production. Second, the properties, how the material properties fit energy absorption requested for crash, despite more and more stringent specification, and while offering significant weight reduction. And third, the methodology with an overview of Valeo composite and crash simulation methodologies whose reliability and predictability accelerate time to market of their application. The presentation will last about 10 minutes, followed by questions and answers. So I invite you to start sharing your question with us by typing them in the right section of your screen in the question tab next to the chat tab. You have also the possibility to upvote the question, but in any case, at the end of the presentation, we will answer all the questions you have. The webinar is being recorded, so you will be able to view the entire program later on gccomposites.tv. We have 2 presenters today. Our first speaker is Sergio da Costa PITO, Structural Components R&D Manager and Composite Material Coordinator at Valeo Thermal Systems. After an experience as Project Manager at Faurecia, Sergio joined Valeo as Structural Components Manager. He graduated from the CESI Engineer School in Paris. Sergio and his team developed and industrialized the first composite bolster for mass production. Our second speaker is Ali KEZMANE, Mechanics Design Leader Simulation at Valeo Thermal Systems. After a PhD on Material and Structure at Mouloud Mameri University in Algeria, and a structural composite master at École Centrale de Nantes, Ali joined Valeo as simulation engineer. He developed key composite and crash simulation methodologies. Thanks again to all of you for taking the time to be with us today. I'm going now to hand over to Sergio and Ali. Enjoy the presentation.
Good afternoon and good morning, everyone. Thank you for participating in this webinar. A few words about Valeo and more specifically the domain we work on, Ali and I. Our product group's scope is to develop structural and airflow solutions assembled and delivered in just-in-time in order to improve safety, thermal efficiency of passengers' cars. Looking for lightweighting solutions, a key driver in automotive for fuel consumption reduction and EV driving range extension, we started seriously investigating composite materials that were easy to process and compatible with plastic injection. We selected a composite material named Organosheet and introduced a lightweight composite bolster in 2018, a world premiere with Daimler. A composite battery casing with the same OEM followed this year. Our latest project is to develop a composite bumper beam solution as showcased here. Let me first explain why we selected the Organosheet in the first place. When screening materials, we looked for mechanical performance and cost aspects. As you can see on the graph, compared to steel or aluminum insert, glass fiber Organosheet solutions offer interesting properties for our purposes. On the y-axis, specific strength represents the material's ultimate tensile strength versus density. On the x-axis, specific stiffness represents the material's tensile module versus density. Vertical and horizontal dotted lines show that if you are looking for lightweighting and robustness, a glass fiber organosheet is to be preferred. Besides, glass fiber solutions remain affordable, whereas carbon fiber is not economically sustainable. That is why glass fiber organosheet was fully relevant for the bolster application, for which robustness is key. Being located at the vehicle front end, the same logic applies for the crash boxes. The second reason why we selected glass fiber organosheet is that it is resin pre-impregnated and can be processed in standard injection machines in one-shot net shape. In a single process phase with prior thermoforming, finished parts are ready to be shipped. The very short production cycle is ideal to address a mass market like that of automotive. From there, our product roadmap comes almost naturally. As we are vehicle front-end specialists, the first application was the bolster, then the Crashbox and bumper beam, which can be located at the back of the vehicle, and the new product line for us, the battery casings for electrical vehicles. As we have developed the competence, discussions are ongoing out of our usual scope, and that is very exciting. The production of the bolster started in 2018 at our US plant in Smyrna, Tennessee. We produce 320,000 per year. This part replaced an hybrid steel plastic solution with a weight reduction benefit of 30%. This world premiere in automotive was recognized by the industry with a PACE award and won an accolade from the Society of Plastic Engineers. For hybrid vehicles, a weight saving of 30% means reduced CO2 emissions, and for full electrical vehicles, it translates into extended range. These are major concerns for the automotive industry. While developing that product, we focused on crash energy absorption, and that is how we built our expertise in composite materials for that kind of application. Composite covers fully contribute to the crash performance thanks to a high level of strength combined with a good ductile behavior. The move to composite crash box development, for which energy absorption is key, came naturally. This part is made of plastic overmolding and organosheet insert and patch. We performed drop tower test and compared our solution with a serial solution in aluminum that demonstrated the significant advantage of glass fiber organosheet in terms of performance and lightweighting. Minus 20% less mass versus aluminum, and the gap is even bigger versus steel. The graph shows that for the same level of energy absorption, a smaller stroke is required.
Performance and lightweighting were of course targeted during the project, but we had also decided to develop a simulation methodology. The objective was to offer good prediction of failure, reaction force level, and part behavior when used for future developments, where severe loading in impact crash is central. It ensures a standard development, and that is highly appreciated by our customers. Our simulation methodology is based on both material cards calibration, including strain rate dependency and failure criteria based on plastic work, so that it corresponds to the physical testing. In addition, we conducted a systematic correlation work with physical tests to validate the simulation protocol. The crash methodology was tested on other applications, and we had the confirmation it is transposable to other products than the ones we presented today. With the powerful simulation tool, we can bring forward the multiple advantages of composite, and particularly one of them, their incompressibility threshold. For the Crashbox, for instance, there is 20 mm difference between the composite and aluminum. For the OEM, this means that they can either reduce the length of the vehicle or increase cabin space or improve crash performance. We have run complete validation procedures, physically testing the product at various speeds, temperatures, and aging states. In total, we ran 100 tests on the Crashbox alone and bumper beam plus Crashbox as well. We have thus reached a significant maturity level that allow us to propose the tool when we work on customer developments.
From design to final part, our crash boxes and front and back bumper beam, including the possibility to add a towing hook, are ready for RFI and RFQs. So to summarize our approach, the composite material we selected offers 20% weight saving versus aluminum and up to 50% versus steel at competitive cost. We built a precise and accurate simulation methodology to support customer development, and we are now ready to tackle any project you would like us to work on, even in new fields. Thank you for your attention. We are now looking forward to answering your questions.
Thank you very much, Ali and Sergio, for this presentation. That was really insightful. We are starting to receive some questions, but don't be shy again, and please continue to ask your questions to Sergio and Ali. So we are going to answer all of them now. I do have some questions for you on my side to maybe start this Q&A session. So you said that you were developing a new project, bumper beam with crash boxes. Is there already any customer interested in this project?
Yes, indeed. We started with an internal project 2 years ago, and since 1 year, we are now discussing and deep diving on this topic with at least one customer, and we are also kick-offing now a prototype phase for the complete beam, not only the crash boxes.
Okay, thanks. I have a second question for you. So how do you integrate raw material properties in your simulations?
So maybe Ali can explain furthermore about this topic.
Sorry, could you repeat the question?
How do you integrate raw material properties in your simulations?
So on the simulation, we developed a complete methodology in order to take into account all of the needed parameters like strain rate dependency and also temperature effect.
Okay, thanks. And my last question for both of you would be, what will be the next applications in your roadmap?
So as you've seen, we started with front-end applications. So we are now extending from front-end carriers to bumper beam systems for the front, but as well we are proposing for the rear. In addition, we got the opportunity to extend to other applications that are out of our current scope of products, which are the battery casings. We are working a lot on these topics as we see a lot of interest coming in from customers. And also we've been working and we are working in other applications such as structural reinforcement components for body in white or suspension components as well.
Okay, thank you. So let's take the questions from the audience now. So I can see that some of you posted your questions in the chat section. Please make sure to post it in the question tab just on the right of the chat tab. So the first question is from David at Jaguar Land Rover, who is asking, what is crush efficiency for crush boxes versus aluminum ones?
So crush efficiency, so I guess it's the difference between the maximum peak force and average force when crushing the crash box. So basically what we observed is that we are able to have more or less the same as for aluminum, eventually even better, depending on the overmolding material we are considering in addition to the organosheet.
And he pursues his question by asking how this material on crush boxes performs with angular loads.
So basically, it performs well. So we, when we did our test, we consider 0-degree crush impact, but as well tilted impact test. So this is something we've been considering during the validations we performed.
Okay. We have another question from David at Jaguar Land Rover. Thanks again for your question. From a recovery point of view, which are the biggest load that these cans can support?
To be honest, I don't have in mind the exact values, but it can sustain very high level of loads. So, okay, I don't have the precise value right now, sorry.
Okay. Maybe approximately, just to give a trend.
It's more than 100 of kilonewtons. It's something comparable to aluminum, by the way. We are able to design and to size the parts, so we perform same values as for aluminum.
Okay. And a question from Warden at AZL in Germany. Are you developing battery boxes for electric vehicles in thermoplastic composites?
So at Valeo, we are only considering thermoplastic composites. So when we are talking about battery casings applications, this is our main focus is on thermoplastic composites.
Okay. A question from Rian at Van Vies UD and Crossply Technology. Do you consider using UD tapes, which are known to be cheaper than Organosheet? Second advantage of UD tapes are the possibility to tailor the blanks better to the loads on the parts.
Okay, so today I won't go into details regarding which are our current developments regarding materials. So we are considering different options. Organosheet is the main one, but of course we are also checking other possibilities. UD tapes can be one of these options. We know the advantages of UD tapes. We know also that it can provide some advantages in terms of part optimization. So this is something we are considering at the moment. So
okay. Next question is from Giuseppe at Fiat Chrysler. He is asking how temperature work on property material.
So regarding temperature today, as we are considering thermoplastic based organosheet, for sure it has an impact on the properties of this material. So we know that low temperature may affect the properties by bringing a more brittle behavior while providing more stiffness and more resistance, basically. So we lose ductility, but we gain stiffness and strength, while higher temperature is providing the opposite, a bit less stiffness and strength, but gaining ductility.
Okay, I hope it's answer your question, Giuseppe. Next question is from David at ESI Group. In terms of cost, is it applicable to any car segments?
I would say today depends really on the applications and the concept we can propose. So depending on that, sometimes we are able to propose something really competitive compared to the replaced technology. So that's why we are able to gain some interest on all the applications we are proposing. Again, it's a question of application selection and also a concept. Some other times, of course, we are not able to be at the same price, so therefore we have another cost that can be discussed for each case.
Okay, thanks. Next question from Julian working at Decathlon. For the cost, is it the same as aluminium solution?
So I think it's more or less same answer as previously. Depending on the application and the concept, we can propose to substitute the existing solution. Therefore, we can show a cost competitive solution or have an extra cost. Compared to aluminium, generally, our target is to be same cost while providing weight saving.
Okay. James at Jaguar Land Rover is asking, how are you joining the crash boxes to the bumper beam?
So this is something we are still working on. So this is part of the advanced developments, in particular the one we are kick-offing. So today there are different options. One of the most obvious is the use of screws, but we are not limiting to this solution our proposals and our investigations.
Sebastian from IDI Composites International Europe is asking regarding the battery boxes and fire resistant, do you pass the GB 38031 2020?
Okay, so I mean, yeah, this one is a very particular regulation which applies to China or vehicles that would sold in China. So yes, in fact, we've been checking particularly this item of fire resistance. So we are working in close contact with different material suppliers. There are already solutions coming into the market that are fulfilling UL 94 V0 criteria. And basically, we are doing some tests in order to confirm that we can pass this test or fulfill this regulation.
Christian at Reo AG is asking what kind of specific material testing did you need to do to enable AFI simulation to predict the real behavior? He supposed that you were focusing on PP and GF only, right?
So clearly, this is during our internal development, one of the biggest challenge. It was not only to develop a particular design which could fulfill the different requirements and compete with aluminium or steel crash boxes, but it was also the ability to define the proper methodology of simulation and also to define all the material characterizations required in order to correctly define the material cards for this simulation methodology. To be honest, we are very proud with Ali of the work which has been done, and this is today one of the knowledge and the skills we wanted to promote today. I cannot go into details regarding which kind of testing we've performed or what are the ones that we are considering. But just to let the audience know that we are not only focusing on one material. Basically, what we did is to find good, smart solutions in order to be able to consider different kind of materials, to be able to react quickly by switching to one material to another one, by doing just the needed test and be able to calibrate the material cards for simulation.
Okay. By the way, I'm moving to the next slide for the audience. If you need to contact Valeo, you have the contact details on the slide if you need more information on the Organosheet material. Next question is from Alain at Renault in France. How do you manage the reproducibility and capability of the process in mass production? Is it 100% control?
So I'm not sure to be clear with the question if it is regarding this particular application or the other applications that are starting in serial production. So basically for crash boxes, we are still developing, so we don't have yet the parts in production. Nevertheless, for parts that are already in production, we have a good reproducibility of the components. So of course we test it and we ensure that this reproducibility is good when we start the production, and we are not controlling it 100%.
Okay. Sebastian from Hutchinson is asking if it is possible, to over-inject the Organosheet to get more complex geometries. And if yes, how do you manage the geometric stability?
Okay, I'm not sure to understand the link between the complex geometry and over-injection, but just to let the audience know that we have in parallel to this work we did on the product development, we also developed solutions to simulate the process, the thermoforming process, and therefore be able to define which geometries we can do, and eventually anticipate the problems during the process.
Thanks for this answer. I hope this answers your question, Sebastian. The next question is from Anna Maria at Sabelt SPA in Italy. What is the polymer matrix you validated?
So today, the two main polymers we've been considering for Organosheet is PP and PSX, but we are extending towards others resins. So this is what we validated. It's mainly PP and PSX, but we are now validating others.
Okay. Jeneke from Snox Automotive is asking what are minimal production quantities to be comparable in cost to the metal production.
To be honest, it's difficult to answer to these questions. It depends really on the concept or the application, and how we can really take advantage of the technology to eventually reduce the number of parts or do these kind of optimizations. So okay. I cannot answer to this question.
Mark at Jaguar Land Rover is asking, have you considered high voltage EDU tray mounting for the electric motor? And how does the fatigue life compare to aluminum and steel? So,
okay, I think high voltage EDU tray, it's some kind of a mounting component which is submitted to vibration. So these are not components that we've been considering until now. And fatigue is probably one of the things we we can further explore for other applications. But for the applications we've been considering until now, it was not really the biggest concern.
Okay. The next question is from Wasim, who is a PhD student. I would like to know if you made the analysis cycle life of these composite parts.
So no, we've not been through the complete life cycle assessment for this part. We discussed already this topic with Organosheet material suppliers. Some of them can provide us detailed data about their materials, but we've not done the complete assessment on the components. Maybe it's something we can further do.
Okay. We have a question from one of your colleagues, Prasad, a system engineer at Valeo. He's asking, can you provide more information about brittleness behavior of Organosheet? Is it more brittle than aluminum or steel for buckling loads?
So hi Prasad. So thanks for your questions. It's It's in terms of ductility, it's pretty good compared to steel or aluminum. That's why, by the way, we've been working on this project, because we saw a good potential to absorb energy.
Thank you. Jean-Philippe from Porsche Industries is asking, in terms of cost reduction, would Valeo expect the same level for battery casing compared to other existing options?
As I said, our target, as soon as we start to investigate in one particular application, is to be cost competitive. So basically, to be able to provide either weight saving and same cost, or be able to propose additional features or benefits, even if it's having an extra cost. So again, it depends on the applications, but the idea is to find the right balance between benefits and cost or over cost.
Right. The next question is from Ilker, but I think you already answered such question. He was asking, have you ever tested UD tapes instead of Organosheet in your tests? So if I remember well, you said you were considering using other things, but you didn't start it yet.
But in fact, we tested already UDs, but this is not where we put the most our efforts right now.
Okay.
But
the next question is from Gilles at Texinoftech. How have you produced this glass fiber or Organosheet? By waving or by knitting?
So these are materials that we buy from different suppliers. Most of them are proposing weaving woven materials, Organosheet based on woven fabrics. This is the mainstream for now. There are other options, but this is the mainstream.
Okay. Sebastian from IDI Composites is asking, why are you interested in thermosets composites? So I think maybe the question is, why are you not interested in thermosets composites?
Yeah. So in fact, it's one interesting question, because today thermoset composites are also good options, but considering our current, let's say, main products at Valeo, which and also main production capacities, it was easier for us to first consider thermoplastic composites, and this is basically what we did. We just thought how we could introduce composites by reusing existing production capabilities.
Okay. The next question from Grégoire at Common Sense. Is it in your roadmap to integrate sensors in structural parts to monitor the integrity and usage of the parts?
It is not in our roadmap, but it's something we can think about, or we've been thinking about, even if it's not our main focus for the coming months or years. I don't know. To be honest, it's something which seems interesting, but we still need to find what could be the real benefit to introduce this in our components.
The next question from James at Jaguar Land Rover is asking at what temperatures did you test the crash structure at?
So it's a good question. We've been considering extreme temperatures. Basically, we've been considering between or starting from -30 up to 70. I guess this covers the temperatures that are seen by the component during the vehicle life. So yes, this is important really, because we know that this part is a safety part, a safety component. So therefore, we need to somehow ensure that we keep good performance of the component at all the temperatures.
The next question is from Jeremy at Clients NP. It's a good question. When this will be available on mass market vehicles?
So for the composite Crashbox or bumper beams, as I said, we are starting an advanced development with one customer. We hope clearly that we will be successful, and therefore we will convert this into a serial application, and therefore this could come into mass market in 2024.
Okay, so Jeremy, you still have to wait a little bit. Next question from Nicolas at Sobel Comp is asking, do you stick Organosheets together? And if yes, what average pressure do you use to make them stick?
Yes, this is an interesting thing, interesting question. We can. This is one of the advantages of using thermoplastic composites, is that we can really fine tune the composite during the process and make something let's say really specific to the application by having one main insert, for example, and some reinforcement patches. This can be done during the process, as I said. Okay, I cannot answer to the second question, which is very specific, but this is something which works very well, and that we've been implementing into our different products with a good success.
Right. We still got a couple of questions. Another one from Jeremy at Clients NP, an interesting one again. What about recycling?
So recycling, it's also one of the reasons why we prefer to focus and to continue to focus on thermoplastic composites. It's clearly one of the advantages compared to thermoset composites. We can in fact manage the recycling, sorry, more or less like for any plastic component. We can regrind the part and reuse grinded pellets or parts by reintroducing it into our process, or to make another material which can be therefore injected to make another component.
Thank you for this answer. Frank at Adient Engineering is asking, can you achieve Class A surface quality with Organosheets?
I think it's one thing which is very difficult to achieve. Class A surface, I know that the requirements or the requirements to achieve this is really high. Nevertheless, the first application we put into the market, so the composite bolster, which is mounted on the Daimler, the Mercedes GLE, is a visible part, and we had to consider this aesthetics requirements in order to provide parts that are having a very good look, a very good aesthetics. So I won't say that it could achieve Class A surface, but it can be visible components. We already demonstrated this on the first application.
Right. The next question from Ronan at Covestro in France. Which high and low temperature levels do you consider, and which materials are you referring to?
So high and low temperatures, I answered a few times before. It's between minus 30 and 70 degree. And in terms of materials, as of now, we mostly focus on PP-based solutions and PA6 as well. And as I said, we are extending towards other resins, particularly in order to also improve this temperature topic. This is one of our motivations.
Antonio at ENEA is asking, did you evaluate the possibility to use recycled fiber or recycled polymers?
Not really.
Okay, next one of your colleague at Valeo, Louis Thiem, is asking, do you have experience in overmolding metal inserts while forming organosheets at the same time?
I'm not sure what he is thinking about when he says metal inserts, because basically we are already doing this, having metal inserts, for example, for the interfaces while forming the organosheet. So maybe I will clarify with Louis later on.
Yeah. So Louis, don't hesitate to contact Sergio directly if it doesn't answer your question. Yoshito at Toray Industries is asking, may I ask, what is the next challenge to be improved on this technology? Material, simulation, process, or mold?
Next challenge, to be honest, I think there's no more, at least at Valeo, particular challenges to overcome to propose these materials and technology for mass production. As I said, we have one first application which is already running since 2018 and one starting this year. We made a huge progress on simulation side. So in terms of accuracy, simulation accuracy, we are able to have same as for steel or aluminium, even for crash applications. So I think now it's more a question of how to ensure that we can be cost competitive. So it's working on the applications, on the concept, the designs, on the material side as well. So
the next question is another question from Alain at Renault, but I think you already answered that question. Have you tried to integrate inside the parts some strain gauge, tag, RFID, CEM solutions?
Not yet. So I answered yes. It's not. We did not investigate this topic.
And we have one last question from Yves at Porsche Industries. He's asking, have you investigated other fibers than glass, such as natural fibers, for example?
Not natural fibers. I'm not sure that. Okay, maybe this could be one further topic that we will investigate once we have completed or we have a few projects, additional projects running in production. Maybe we will consider this topic. But we don't see it, at least we don't see any particular interest or in the applications we are considering. That there's no particular questions regarding this kind of materials.
Okay, we are keep receiving some questions, so we still have 10 minutes to answer them. Do you have test induction heating to decrease the cycle time of the part production? This is a question from Edouard at Rocktool.
We've been testing different options for the heating. This is part of our knowledge, so I won't answer, or I won't disclose what we are considering, or if we've been considering this kind of heating.
Dorian at Epsilon Composite is asking if you think of using carbon fiber too for structural parts in automotive.
So of course carbon is one of the potential options for fibers, but to be honest, as I said, one of the our main interest is to be able to propose solutions that are cost competitive. Therefore, I don't think carbon can be cost competitive for mass market, mass production. So we've been mostly focusing on glass fiber until now, and for some applications, very specific applications, we've been looking and checking carbon fiber. But yes, this is for niche markets, niche applications.
Okay. James again at Jaguar Land Rover is asking, what is the typical cycle time for making a Crashbox?
So cycle time with this technology is comparable to the ones we have for injection. So it's a single digit in terms of minutes. It's very short compared to thermoset technologies.
And at last, Antonio from ENEA is asking, what is the TRL of this composite structural part? Can you consider them to TRL 9?
So for the Crashbox, I think not yet, because as I said, we still need to go into serial production. But for other applications, yes, for sure.
Okay, all right. Thank you, Sergio and Ali, for this great presentation and for answering the question from the audience. Again, thanks to all our attendees. If you have any other question or you want more information about Valeo Organosheet material, you can contact Sergio and Nadine. You have their details on screen. This webinar, again, has been recorded, so you will be able to view it again online on gccomposites.tv. Our next webinar is scheduled on December 1st with Elkem Silicones. and the topic will be about the secret to lowering production cost in composite molding. You can check the details of gecomposites.com if you wish to register for free. We appreciate everyone's participation today, and we hope to see you again at next GEC Composites webinar. Stay safe and have a great day, everybody. Bye.
Thank you, Benjamin.